Have you ever been given two decks of cards and told to sort them? Well, as a computer science student, you should be familiar with merge sort. So, what is merge sort? Merge sort, a comparison-based sorting algorithm that utilizes the divide and conquer approach. So, what is divide and what is conquer? Let's imagine we have an array A or a list A composed of n elements, as shown here. So, divide is imagining if I can divide this array into smaller sub-problems if I want to sort it. If I'm giving this array, is it easier for me to sort it? Or this array, this part of the array, is it easier for me to sort it? And conquer is that magic spell that allows me to say yes to this question. Yes, if I have a smaller problem, it will be easier for me to solve it. So let's take a look how merge sort utilizes this merging and dividing approach. But first, to see how merge sort merges and conquers, let's answer this question. Imagine we have two arrays or two lists or two sets composed of sorted elements in ascending order, as shown here. If I want to sort them into one big array or combine them into one big array, how shall I do this? Okay, let's do it. We shall put two pointers here and here and compare each of those elements. If we found that one of these elements is smaller, we place it in the big array and we continue. How we continue? We shift the pointer where we chose the number. We continue the process. 4 and 7. Who is smaller? Of course 4. We continue. 7 and 7, they are the same. So we choose whichever we want. Let's choose this. We shift the pointer on this. 7 and 8, 7. 9 and 11, 9. And we add the rest elements. So as you can see here, from two both sorted arrays, we have one big sorted array, 1, 4, 7, 7, 9, 11. Yet, how shall this help us in solving this problem? How shall this help us in solving and sorting an array A? How shall we create two sorted arrays from a subproblem? Recall that an array of one element is always sorted. So, if we keep dividing this array A into two parts until reaching an array of single element, shall we use this approach to continue? Let's discover. So guys, let's try and create a way or invent a way to let us use that magic spell that transforms our subproblems into two sorted problems in order to solve them. Here we have an array A of n equal 9 elements. The length of this array is 9 elements. If we keep dividing the array by 2, meaning 7, 1, 5, 4, 14 is in this part, 1, 9, 6, 10 in that part, we divide it by 2. And we keep this process to every subproblem generated until no longer able to divide the array, meaning we reach an array of one element. Now, recall that an array of one element is always sorted. So, we have two sorted arrays. We have two sorted arrays, so we can use that magic spell, that merging algorithm that enables us to combine two sorted arrays into one big array. So here, let's start using. So here, Let's start using this algorithm. Which is smaller, 1 or 7? 1. So we put 1 here. 2 pointers and we utilize. We add the rest of the elements to the array. Now this is sorted. 5 is already sorted because it's an array of one element. So we continue the sorting algorithm. 1 and 5, 1. So here we add it. We shift the pointer by right. 5 and 7, 5. And we add the rest of the elements. Sorted. Now we continue on this part. Now we have two sorted arrays. So we can sort this bigger array. Using the same approach, of course. We continue the same process on the right part of the tree. Now, by solving the smaller sub-problems, we are able to solve a bigger problem until reaching the main problem, which is sorting an array A. So, we will use these two sub-problems that we solved from previous smaller sub-problems and merge them using the merging algorithm into one big sorted array. So we utilize also the same algorithm. We put two pointers and go with them. We put 1, we shift the pointer, 1, shift the pointer, 6 and 4, 4. So as you can see, we have managed to sort the array. So now, let's take a look how the code would look like. So guys, this is the long code for what I was talking about. First, you can see the dividing approach here and the conquering approach right there. The main method for the sorting algorithm is the merge sort. It takes an array A, which we saw, and two pointers left and right. Initially, this would be 0 and this would be the end of the array, which is n. First, it checks if the length of the array is greater than or equal to 2, so it needs to divide it as we show in the recursive tree. It calculates the middle element by adding the left and the right pointer divided into 2, and then it calls itself with the new left and mid. This would denote the two sub-problems that we saw. Then this will repeat because it's a recursive call. Left will become here and mid will become the new right element. So it would call itself again, creating the sub-problems we saw right here. Until reaching the base case, which is a single element, an array of single element, and would not be greater than or equal to 2, then it will call the merge algorithm. The merge algorithm will work as simply as we saw. It creates first the two temporary arrays, the left array and the right array. You can see this as the pointers pointing to the first element of the left and the right array. I equal to 0 and j equal to 0. And k is for the main array, which is A. So now, while I is less than nl and j is less than nr, where nl and nr are the length of the left array and the right array, to ensure that there's no array out of bounds, if the left of index I, meaning the element in the left subarray, is smaller than the element in the right subarray, so we should place it in the main big array. A of k is equal to left of I. We increment the pointer by 1 because we have finished with one element and we don't need to recheck it again. Else, the opposite occurs. The smaller element is in the right subarray, so we take it from the right subarray. We increment by j and we always increment by k, which is the pointer responsible for the main array. When we finish this, some elements might still be appearing in some of both arrays as we saw, so we have to copy the remaining elements in one of these two arrays by using this approach. While the index is less than NL, which is the length of the left subarray as we saw, we just copy the elements into an array K. The same goes for the right subarray. A note to see here is at each call, one of these two will be called. Now what about the time complexity of merge sort? Is it better than previous sorting algorithm or no? So how would you analyze that? First, we will analyze the dividing, which divided the array into smaller arrays. If we take a closer look at this, we shall see that the length or the height of the tree, of the recursive tree generated by calling these two merge sorts is log n, where n is the size of the array. Also, at each call, we're calling the merge algorithm, which is responsible for merging the two arrays. Here, the while loop and the while loop, including the I and the j, is iterating n times, which is the length of the array given to the merge. If we combine these two together, we have log n calls for the dividing approach and n for the merging approach. We will have n log n. And this doesn't change even though the array is completely sorted, because we would have to divide it also, because we don't know if it's sorted unless you have made an algorithm to check first if it's sorted or not. This has been the CS tutor. Thank you for watching. Please, if you have any questions, put them down below, and see you until next time.